Well, now we are going to discuss about the normal forms that are required to uh, reduction from a given context-free grammar rules. You are need to convert into certain forms, which is called as one is a Chomsky normal form, the Chomsky normal form, and this is a Gribich normal form. And these two are commonly known as a CNF and GNF. So what does mean by the Chomsky normal form? What is the number of restrictions that is imposed in case of Chomsky normal form? Let us discuss about that, and then we will see that how this conversion or this reduction will be took place. So if CNF is given, if CFG is given, the certain rules are given. So you have to, if you want to convert into Chomsky normal form, that reductions, it will be restricted in production rules. It will restrict some production rules. Beyond that restriction, you can't move around. So you can't add any other production rules if it is asked to have the Chomsky normal form. So what is this? A non-terminal can be produce a only a non-terminal. That is a restriction. So a non-terminal can only produce terminal, a terminal. And in the left-hand side of a production rule, you must have one non-terminal. That is the definition of CFG. But in right-hand side, you must you cannot have a more than two non-terminal. So as you know that in case of CFG, it is given that in produce non-terminal produce in bracket in nut in union and terminal, non-terminal and terminal union and star. So you can have any number of non-terminal and terminals that is given in a CFG, but it is restricted in case of CNF that you can have only two non-terminal, only two non-terminal. So n shows the number of two non-terminals. So it will just support introduce NN. If you have only, you can have a introduce A, that is small a is a any non-terminal, but the number is only one. Okay, and especially the starting symbol can be null. That's it. So these three, so these three are allowed, and none of others are allowed in case of Chomsky normal form. So this is a restriction that is imposed by Chomsky normal form. You have to convert the certain CFG into Chomsky normal form or CNF. How you can do this? Let us see the what is the algorithm. Algorithm is proposed. In algorithm, you can see that if the start symbol occurs on some right hand side, create a new start symbol S. Mind it, there is another restriction that you have to impose here. Start symbol, the special symbol start cannot be in a right hand side of a production rule. So that's why if start is start symbol is available in a right hand side, so then you need to make the S as a new symbol S prime. So what do you mean? Suppose if you have this type of production rule, A produce AS. So AS is in the right hand side also. So this is not allowed. So what you do, you will do above that, you make a new start symbol as a S prime to make it S produce S. So what does mean? Now this is a simple non-terminal, and non-terminal produce two non-terminal is allowed. So now this become a valid production rule in a CNF. So it was a earlier CFG that is not in a form of CNF, but if you add as a S prime to create a new start symbol and new production rule S prime produce A you have added, so then it becomes the valid production rule in case of CNF normal form. Okay, so that is the first step discussed. Second step is, now recently just we have completed to remove all of things. One is, first one, you need to remove you need to remove the unit production. First you need to remove the null production. As you can see that after null production removal, you might have some unit production also, right? Just few minutes back, you get this example. I showing that this type of production rule you get. So B produce A is also a unit production. So you can remove it. So the next one is, you need to remove the unit production. So once the null production is removed, you will get the simplified production form. Then you need to remove the unit production. Okay. So that is the third step that you have to follow. Now what is the fourth step? Fourth step is a very important step, and you can summarily that you will understand by iterative approach you required. Suppose you can you replace the each production, that is, suppose its production rule started with a produce B1 to Bn. So you can consider, if this like this, for simplicity, for example, I considering it is a B1, B2 and B3. Instead of taking about the Bn, I just giving the 3. Now as it is a more than 2, so what we can do, we can replace by a new non-terminal as called C. So what you can make, we can make A produce B1C. So this is the form which is allowed in case of CNF. So what I found C produce B to B3. Now if I have another one B4, so I will take entire non-terminals to as a C. So it will become B4. So definitely the C is not allowed. So you will take B3 and B4 as a D, new production rule you will add. So B2D becomes C, is allowed production rule, because you can get that it is always 2. So D become B3, B4. So in this way you can see that is possible if you have a n number of where n is greater than 2. So you will relatively replace that A1 B1C and C will be dot dot B2N and so on. Okay, and repeat the steps until you get that all are become 2 in the right hand side, 2 number of non-terminals. Why the step 4 is given inside that? Because you have a condition that you should not have more than 2 right hand side non-terminals. So that means you are somehow reducing the parts tree from giving from getting to M array, N array. So if you have any number of right hand side non-terminals are allowed, so we'll get M array tree, right? So M way tree we'll get. So it starts from B1 to Bn. It always will be very difficult for for general any production rule. You will not be able to get the same structure of parts tree. So to convert it, although the level of discussion will be increased, a level of uh, tree will be increased, but you will have only a binary tree. Only a binary tree. Here is a B1 to B4. This, for example, B1, B2, B B1, B2, B3, B4, and the B5. Sorry. So you can eliminate one string. So what you able to reduce it? You able to reduce it by B1 from that to C. Again, C is reduced to B2, D. Again, D is reduced to B3, B4, right? B3, B4. So you can see the parse tree become a just a binary tree. You do not bother about the m-nary tree. You just convert into the parse tree into a binary tree. But in that case, it's not, this is not a binary tree. So it becomes the general for each and every production rules. You have to build only a binary tree. So that is the one important thing that required, or that is restricted in case of CNF, because your parts tree will be simplified, or writing a code will be simply when you developing a CFG. So this is the step 4 explained. Now come to the step 5. What does the step 5 going to discuss? Step 5 is supposed to tell you that if the right side of any production is like terminal and non-terminal both, so that are also not allowed. So what you can do? So then what you can do, that you replace that certain terminal to a new production rule from X produce A. So earlier it was a X produce AB. So you make a new production rule for, in that case, if you have a right hand side of a production rule is a terminal and non-terminal mixed. So you will make a terminal to a production rule of non-terminal producer terminal. Sorry. Okay. So then you going to add this production rule, because this production rule is allowed. Non-terminal producer terminal is a allowed production rule. So that's why you add this, and as a result, what you will get the non-terminal producer non-terminal. So you will get another allowed production rule, that is non-terminal producer non-terminal. So it is the fifth steps that I have discussed, and repeat the steps. Jodi in case of B there is a more than terminal is there, you have to repeat for that to get back only the two non-terminal in the right hand side. Okay. So this is the end of the CFG to CNF conversion. So these all 5 steps you have to complete. So 5 steps. The first step is the if S is found in the right hand side, you have to put a new starting symbol S prime. Then second is a removal of null production. Third one, removal of unit production. Fourth one, if the production rule is right hand side is a more than two number of non-terminals, it needs to reduce to two number of non-terminals by repetitive recursion process. And fifth, if you have in the right hand side terminal and non-terminal both, so then what is the if the non-terminal is present, then you produce a production rule that non-terminal terminal is present, then you produce for that terminal a production rule the produces a non-terminal to terminal, so that will be added. So that is the total 5 steps required for doing the conversion of a production CFG to CNF form. Let us now see an example how this conversion took place. Here is the example I have given. So this is the very simple example that I have added. You can see that A is A. So definitely S is the right hand side first, you can see. So you can put a S prime or S0 as a new starting symbol. New starting symbol, you will add a S0 as a S. So S0 S you added. So that's why S is the right hand side is no longer exists. Okay, because it's not a starting symbol. It's not a starting symbol. Starting symbol with a new non-terminal S. Okay. Now S produce A S A. This is not a acceptable in a CNF because three non-terminals are there. So let's see how I will produce. But the first step is done. Now second step, this come to the step 4. This will be eliminated in step 4, right? So now I need to remove the null production, as because B produce B and null is there. So I can say that it will be only the B produce B. It will be only the B produce B. But in case of A, it will be added to A produce B, A produce S, and A produce null. Because when you removing B A produce null, so B produce null, it will create A produce null as a new production rule. So definitely you have to remove A produce null as well. Once you're going to remove the A produce null, so it reflects back to first here. It will create a three different consecutive production rules. That is A produce AS, because if you produce this A to null, so it becomes A produce AS. If you make the first A to null, so that becomes S produce SA. And if you make both the null, so then it becomes S. Okay. Now you are going to remove the null, so that's why you are finally get A produce B or S. And it was earlier you found that B produce B. So after step 2, you have this set of production rule in your hand. Now you can see there is only one uh, unit production you have. So you have not only one, you have a 2 unit production rather, because you have 1 unit production A produce B and another unit production is produce A. Let us now erase first. Yes, in a step 3, now I need to remove if there any other if you have any unit production. So definitely S produce S, basically S0 produces S, okay, and S produces S is also unit production. So you can remove directly to the S produce S because you did not read, because it is a unit production. So you can see that there is a S produce S. S produce S is arrived from putting the null of A. So you can remove that first one, and then you have another production rule is S0 produce S. That also unit production rule. Okay, that you supposed to remove. So if you remove, then what you get? That you get the S0 instead of S, you can put all these production rules, right? So if you remove the unit production of S0S, so you will get S0 produce this, right? And S is this one remains, right? There should be a comma. Sorry, there should be a comma. Okay. Now you have a chance to remove the A produce B, because it's also a unit production. So if you want to remove it, so then you have a value of B produce B. So if you want to remove the A produce B, just you put the B produce value of B. So you get A produce S and A produce B. Now you have another unit production rule, that is A produce S. So if you want to remove the A produce S, then what will happen? The whatever the value of S produce is there, so that will be converted into A produce values. So instead of S, what are the possible values of that? That is A produce. So A produce S A S A S, A B, A S, and S A. So that all become A produce this. So after removing the A produce S, so how many null production I have removed? I have removed S produce S, then I remove S produce S0, then I remove A produce B, then I remove A produce S. So ultimately I get, after ending the step 3, this is in your hand.
Sir, এগুলো তো unit production, নাল তো আগের গুলো ছিল।
This is the unit production, sorry. These all are the unit production. So in the step 3, we are removing the unit production. Now the step 4 will be concentrating on that right hand side of any production rule should not have more than 2 non-terminals. Okay, so you can identify the what are the production rule you have a more than 2 non-terminals, that S0 produce ASA, S produce ASA, and then A produce ASA. These all are the more than 2 non-terminals. So in that case, you need to add new symbols. So that I discussed that this is the 3 possible production rules that don't have more than 2 that have more than 2 non-terminals. So which actually violates the 2 non-terminals in the right hand side. So you will apply for that. We can consider that either SA is a X. Okay. So if I produce that X, SA is a X, so it will generate the new production rule as a X equals to SA. So as a result, that will go for S0 equals to AX. Rest are remain same. and S equals to AX rest element same, and B equals to AX rest element same. So this become the after end of step 4. Now step 5 is what? Step 5 you need to check whether on the right hand side is a combination of terminal and non-terminal are there or not. So you can see S produced AB is a combination of terminal and non-terminal both, that does not allow, and S S produced AB, that also same, and A produced AB, that also same. So you can consider that A as a Y. So A as a Y, so you get that YB, A as a Y. So Y produce A, so you get S0 equals to YB, then S equals to YB, then A equals to YB, rest are same. So that new production rule you have added, Y produce A. So in a step 4, S produce X produce SA, and in step 5, Y produce A. These two new production rule you have added to form that GNF, CNF. Sorry, this is a CNF Chomsky normal form. So this is the ultimate Chomsky normal form, which follows the 3 or rather 4 rules which I am supposed to follow. That is, the right hand side should not have more than two non-terminal. First, left hand side definitely non-terminal. So right hand side may have single terminal. Yes, right hand side should not have starting symbol S. So because the starting symbol is a S0 now. So okay, and starting symbol can be null. That is not coming in the picture. So you have followed the all 4 rules, and that is finally your CNF form. Okay, so that example is actually explaining the all 5 steps. The steps are first very simple. You have to remove that if the right hand side of a production rule have a starting symbol S, so you have to need a new starting symbol S called S0. And second one, if you have a unit a null production, you remove the null production. Third one, if you have a unit production, you remove the unit production. Fourth one, if the right hand side number of non-terminal is more than 2, you have to reduce to only 2 number of non-terminals. And step 5, if right hand side of a production rule is a combination of terminal and non-terminal, then terminal should be produced to non-terminal. And finally you will get the all set of production rule which will support CNF. So this is called CNF form of conversion you have done from the given set of production rules. So that is the thing of discussion of conversion of production rule from of a CFG into CNF forms. Thank you.